This is Kadir here, and this is just going to be a quick video on Solidworks' sketching tools and also their relations. So let's get started. So this is just like a little table of content. So today we're going to be going over lines, circles, arcs, rectangles, fillets, and then sketch definition and also sketch dimensions. So the sketch menu looks something like this in SolidWorks, and we'll actually go into the software in just a second, but I'm just gonna go over like all the features we have in like presentation style, and then it'll be easier to understand in the software. So the first thing we have is lines. So again, lines, very simple. So it's just a straight line from one point to another. And as far as like the parameters goes, so if you look at the SolidWorks example, you can specify like a length of your line and then what angle it forms relative to something else. So your two parameters are going to be length and angle, and usually what you do is you just make your full shape and then end up connecting 2 points with the line. So these parameters are going to vary depending on how you use it. So next up we have circles. Again, circles are also really simple. So you can specify the diameter or the radius in SolidWorks, and then the center point, meaning where your center of the circle needs to go. And then next we have a slightly more complicated topic, which is arcs. And I don't have pictures of the SolidWorks diagrams, but it's very similar. So we have three types of arcs, okay? Tangent arcs, 3-point arcs, and center point arcs. So what a tangent arc does is it will, when you start a tangent arc, it'll always start it with a tangent relation, meaning that whatever line or curve you start it on, it's going the arc that's going to form is going to be tangent to that line or curve. So if you notice here, we have a straight line coming this way, and then when the arc forms, you notice that this line is tangent to the arc. So if you make this a full circle, if you make this arc a full circle, that circle will be tangent to this line. Next up, we have the 3-point arc. So this will have its own use cases. So the 3-point arc, you can specify 3 points in the arc. So you have your starting point right here in the center, and then you have your ending point, which is going to be where your arc ends, and then you have a third point, which the arc will pass. And having 3 points will define like a full circle, and because you have a starting and an ending point, you can specify an arc of any like radius or any angle based on just these measurements. So I can move this line over here and it'll make a really like flat but large radius arc between these three lines right here. Or I can place it like way back here and it would try and make like a full circle. And then lastly, we have a center point arc, which is you specify the center of the arc first, and then you can specify like the starting and the ending point. So let's go into the software really quick and actually just take a look at this. So I'm already in the sketching menu, so let me leave that. And I can press Ctrl and 7 on my keyboard to go into the isometric view, and it says right there. So I can click sketch, and I'm just going to select the front plane, and let's look at this. The arcs, all the arcs are going to be under this little drop down you see. So in this drop down, I'm going to select my tangent arc first. Actually, let's draw a line first. So I'm going to draw a line, something like that. And then I'm going to select my tangent arc option. And the symbol for that looks something like this. So when I select this, and I go over to this line, notice there's a few relations that come up already. We'll talk about what these mean in just a second, but as I start the tangent arc, you'll notice that wherever I move it on the screen, that starting point is always tangent or perpendicular. So right now it's tangent, and I can go back and then come out like this to make it in tangent in other directions or perpendicular to it. So this is going to be a very useful arc that SolidWorks has, and you're going to be using this a lot because when you do something like this, you can get nice corners and stuff like that. Okay, so I'm just going to put an arc down, something like that. So next, I'm going to go back to this drop down, and I'm going to select my 3-point arc. So the 3-point arc, if you remember, we have a starting point, and now it's trying to like approximate an arc to the ending point. So let's say my ending point is all the way back here. So I select my ending point and it automatically finds a center for it. But as I move my mouse, the center is going to move because now what's going to happen is that SolidWorks is going to try and find an arc that passes through all 3 points we just plotted. So if I were to place the center like right next to these lines, it's going to be an arc that's basically like flat, and as you can see the radius is like really big, like 85. Whereas if I move it like closer, you can see that the radius shrinks to almost just 1 or 2. So let's say it's like right there for now. So now we have 3 points on the arc that are defined, and we can move this around. And lastly, we have our center point arc. So the center point arc, again, so you specify a center. So let's say I want the center of my arc to be on this line somewhere, right? So I'm just going to click on that line, and notice it's very similar to drawing a circle. So I'm going to select this point as my starting point, and notice I can just drag the arc out as far as I need it to go, depending on this center. It's always going to maintain that same radius. So let's say I want my arc just to be that big, and I can just stop right there. And those are the 3 types of arcs in SolidWorks. And again, so like you guys saw, the parameters vary. So for some of them it's just a radius and an angle. For some of them it's more than that. And we'll look at how we can fully define all our sketches in just a bit. And then next we have rectangles. Rectangles is funny because it seems simple, but it's really not. So, I mean, I guess once you understand it fully, it is, but there's 3 types of rectangles that we need to wrap our heads around. So, first you have your corner rectangle, which is the simplest, and I'm actually going to go into SolidWorks and do it right now. So let me just get rid of all this. Okay, so our corner rectangle is just the rectangle with the 2 little dots on the corners, and I can specify one corner and then specify another corner. Most common type of rectangle, and you'll be using this a lot. But we have 2 more types. We have a 3-point rectangle, which will be very useful when you're trying to make specific angles and stuff you want. So if I go into here, actually there's way more than 3 types, but if you look at this, you have the 3-point corner rectangle. So I can specify 1 point, and now it's very similar to a line. Okay, so and then I can specify the 2nd point, and now I can drag this out to a 3rd point, which will make a rectangle like that. And then similarly we have a center rectangle, which is also very useful. So center rectangle, what we do is we actually start with the center of the rectangle. So like right there, for example, and now I can drag my mouse out to make a rectangle that's like perfectly centered to that point we just plotted. And this will also have some construction lines. So construction lines are like these dashed lines, which are just there for reference, but don't exactly like extrude or serve a important purpose in your final design. So if you notice, the reason the construction lines are there is to find the center. So when you cross these 2 lines, the point of intersection is going to be your center, and that's just there to visualize that. And then lastly we have another important topic. It's called sketch definition, and this is a different software, but in SolidWorks we have a little indicator right here on the bottom that tells you if your sketch is fully defined or not. So I'm just going to delete all of this right here and just have this single rectangle. So anything that is blue is not fully defined, okay? So we need dimensions to go along with the sketch, and without dimensions a sketch is pretty much like useless because there's no constraints. So for example, as far as SolidWorks is concerned, this rectangle right here is the same as this rectangle right here because we never specified any dimensions for it. So let me just look at this really quick. Yeah, so sketch dimensions, that's what we're going to talk about next. And yeah, so let's go back into SolidWorks, and I want to talk about a very important tool that you guys are going to be using like constantly throughout the CSWA and just SolidWorks in general, and that is the Smart Dimension tool. So the Smart Dimension tool, what it does is it basically, you can specify pretty much anything, be it an arc or a line or a point, whatever. You can choose those and then specify distances between that and something else. So first thing I'm going to do is actually change this IPS to mmgs, so it's in millimeters. It's just much easier to work with that. So I'm going to go back into the sketch now and then click Smart Dimension. Notice how there's two lines that are blue, right? First I'm going to specify the height of the rectangle, and let's say this is going to be 30 millimeters, right? So now we know that this part is 30 millimeters, meaning I can't shrink the rectangle down anymore. I can only move it in this direction. So even if I hold a corner and try it, nothing's gonna happen in the 30 millimeter side. So now we have one more defined line, and that's good. But our sketch still says it's underdefined because, again, as far as SolidWorks is concerned, this rectangle is the same as this rectangle because there's no dimension specifying how big it should be. So let's do that. So what I'm going to do is select this line, and let's say this one is 50 millimeters, right? So now, notice how our indicator went from underdefined to fully defined. Now, even if I try grabbing the rectangle and try moving it, it will be fully defined and will not move. So another really interesting thing that I would like to show you guys is, so I'm going to do the exact same rectangle and I'm going to dimension it to be 30 millimeters by 50 millimeters, right? Okay, so notice now the sketch is still underdefined. Why do you think that is? It's because the sketch can still be moved in pretty much any direction. So we don't have an absolute positioning for this rectangle right here. Even though the rectangle is the same, we don't know where the rectangle is located. And that's where this origin comes in. So in SolidWorks, this little red arrow you see in a sketch is the origin. And what this does is it just gives you like a starting point for your sketch. So it's important to always start your sketch at the origin because, as you noticed, as soon as I move it to the origin, we know exactly where our sketch is. And that makes all the difference. So what if you want the sketch to be a little bit further away from the origin? Well, we can do that too. So let me delete this relation really quick. Okay, so now let's pretend like we have our rectangle over here and we have our origin right here. I can actually use the Smart Dimension tool to specify, again, the distance between 2 points and say this is like 45, right? And now we have a little bit more defined but still underdefined sketch, so I can still move it up and down. And let's change that. So the distance from this to this is going to be 10. And now we have a fully defined sketch because SolidWorks knows exactly where this rectangle is in space because we have all the dimensions specifying where we need it to be. So there's one more type of definition that we really don't want, and that's called over-definition. So let's say, okay, so we already know that this length is going to be 30 because it's a rectangle. But let's say I try adding another dimension here. It's gonna have issues. So the whole thing's gonna turn yellow because it's over-defined. And if I click OK here, oh, hold on 1 second. So let me delete this and let's try this again. So I'm gonna change it. Yeah, and now you can see there's a warning and it says over-defined because now SolidWorks is confused because this measurement right here is 30, but if I delete this and do that process all over again, I can specify it to be like 45 even. So the same line cannot be 30 and 45 millimeters at the same time, and so that's going to cause issues, and we need to make sure that our sketch is never over-defined. Okay, so now that we learned about lines, circles, and rectangles and arcs, let's talk about relations, sketch relations specifically in SolidWorks. So I'm going to remove all this and we are going to go back to the presentation. So this is actually a presentation from Fusion 360, and in Fusion 360 it's called constraints, but technically it should be just relations. So let me change that. Okay, so there's 9 main types of relations, and there is actually a nice chart that has all these relations, and I'll put the link for this in the description. But I'm just going to walk over like the presentation I have, which is I feel like a little bit simpler than this. So yeah. Okay, so first we have our horizontal and vertical relations. So you can set a line, 2 points, or a single point to lie like directly on the vertical or the horizontal axis. Okay, so in SolidWorks, this is going to look like just a simple straight line. And if I just draw some random line, again, this is going to be extremely underdefined, which is fine, okay? So if I click this line, you see this option that says existing relations and add relations. So if I add the vertical relation, notice how the line just straightens out. And although this line is defined, this point is not. So I can change the height of the line, but I can never move it from side to side now. Whereas without this relation, if I delete this relation right here, I'm just pressing the delete key, I can actually move the line side to side. Similarly, I can select this line and do the horizontal relation, and now it's going to make it horizontal. So when you're drawing like a complex shape and it's got all these horizontal vertical stuff, it might be useful to just put those relations in before you go in and dimension it, because then your drawing will be like slightly constrained, so your dimensions don't fully mess it up. So that is the horizontal and vertical relation. So next we have coincident, and coincident mates or makes two lines, points, or curves, or pretty much any sketch entity like touch each other. So if I go into SolidWorks and let's say I draw a second line like right there, okay, and let's say I want this point to be always on this line no matter what. So I can select this point and I can hold shift and select this line now. And notice how I get a few relations here. So coincident is one of them, and if I click that, notice how the point is now on the line. It's always going to be in the same like axis as this line no matter what. And even if so let me delete the horizontal relation on this line, and even if I move this around, notice how the point always still stays on that line. And again, like relations and dimensions are like supporting each other, so it's important to use both, okay? Because a sketch is going to be hard to fully complete, especially like the complex sketches you see in like a CSWA exam. It's going to be challenging to just finish one of those sketches with just dimensions, although it is possible. But it is important to use relations whenever possible, because again, these are like life-saving tools. So next up we have the tangent relation, and as you can probably tell from tangent arcs we learned, so a tangent relation, what it does is it makes a curve and a straight line within a sketch intersect at a single point or tangent to each other. And this little image you see also like is a visual representation of what's going on there. So here, I know this is still underdefined, but let's just work with the relations we have. So what I'm going to do is I'm going to draw a circle like right there, okay? And let's say I want the circle to be tangent. So what I can do is I can select the outside of the circle, hold shift, select this line, and it'll tell me all the relations that can go with this. So if I click tangent, notice how now the circle is, if I zoom in like a lot, the circle is actually touching the line in just one point. And again, if I try and move the circle, it's always going to be there. And if I move this line, similarly the circle is always going to be tangent to satisfy that relation. And if a relation cannot be satisfied, like it's just going to look weird. Like for example, like this line is, this point is technically on this line, but if I make this smaller line parallel, you can see how it starts to have issues with being collinear. So it's important to remember that. And again, now this has moved over to the side, so I can move this back here. So SolidWorks will do everything in its power to satisfy all the relations. So let's add, again, let's go back, add the horizontal relation here, and then let's make this thing vertical. And another cool thing about horizontal and vertical is right now, if you notice, I can move this line around, right? And then I can also move this circle around. But I can actually make this line and this point, or these 2 points, vertical. And what that's going to do is it's going to draw like a virtual line here and make that vertical. So if I make this vertical, it's going to be always like linked, essentially. So going back to our presentation, so these are like the four most common, I would say, relations. So you have your tangent, which is, I think, is going to be on like basically every practice or part you make, and then coincident, and then horizontal, and the vertical. So next we have another set of relations that are a little bit more complicated but also very useful. So first of all, we have the equal relation, and in SolidWorks what that does is, let's say you have two lines, or here, let me delete this and then draw another one, right? Something like that. What the equal constraint does is it actually just makes the distance of the two lines, or the length of the two lines, equal. So if I click equal right here, if I adjust one line, or I have to fix it to a point, but if I adjust the length of one line, okay, so here's what I'm going to do for the purpose of demonstration. So I'm going to define this to be 30 millimeters. So this is fully defined, and now if I change this, notice how the distance of that other line also changes along with this, because they're both equal now. It's set to be related to each other. And then next we have the parallel constraint, which is, again, pretty self-explanatory. It makes two lines parallel. So if I click this line and the other line we just made, I have the option to add a parallel constraint to that. If I add the parallel constraint, these lines are going to be parallel. So if I move this line now, that also changes to make sure it's always parallel. And again, I'm just kind of placing stuff randomly. There is going to be a few examples we're going to see later to see how these constraints are actually being used. So yeah. And then lastly, we have the perpendicular, which, again, so if I draw a third line, like right there, now it's not at all perpendicular, but if I select these two lines and then click perpendicular, it's always going to be forming a 90-degree angle with this line right here. So if I move this, notice how that changes to always be perpendicular. And then we have our fix slash unfix relation. This one you don't really use as much, because this relation is like for the worst case scenarios where you can't define a sketch but you need to like freeze something in place. So for example, like if I draw a line right here, so and I fix these 2 points, so for example I have a relation to just fix, and then if I fix this point too, it's going to fully define that line, because like as far as SolidWorks is concerned, we're just saying, okay, this line is never gonna move, just keep it here. And this is useful very rarely. I would almost never use this, because again, this is technically still an underdefined sketch, because although like this line is defined, we don't know exactly where it is, and that might cause issues later. So I would just rarely or never use this relation, but it's still an option, and I'm just letting y'all know. Okay, next we have midpoint relation and concentric. So these are pretty similar, so let's go over both of them. So midpoint, if you draw a line, any line in SolidWorks, you're always going to get that little center point. So if I just hover over this line for 1 second or so, you can see that I'm getting a center point. So let's say I make another line, and I want this point to always be in the midpoint of this line. So if I hold shift, select these two lines, or this line and a point, and you can see what I selected over here. So I selected line and point, and I can click midpoint, and now if I change the length of this, it's always going to be in the midpoint. So notice how the other side also goes up. And similarly, if I move this, it's going to change. So yeah, those are the main most important constraints that you guys need to know for the CSWA exam and in general. Oh, and concentric. Completely forgot about that. So concentric, what concentric does is it just um, basically like makes the centers of two curves the same point. So for example, if I draw like a circle right there, and I want this circle to be concentric to this other circle, I can actually select these two circles, and you can see the make concentric relation right here. And when I click that, notice how the center of the two circles are the same. Similarly, I can do the same thing with an arc. So let's say I'm making a 3-point arc, right? Because this doesn't require the specification of a center. And let's say I want this arc to be concentric to this circle. Make concentric, and now it'll be moved, so it's always going to be the same center point. So now let's take a look at an example of a sketch that uses both dimensions and relations and see how we can do that. Okay, so this is just a little example from the CSWA like practice questions, and this part is basically just a simple sketch and an extrude, so it shouldn't be too hard to make. So let's get started on how we can do this. So here, let me just pull this tab out so it's easier to see. Oh, hold on. Okay, so Solidworks, I'm gonna go into a new part, completely new part, and where's this? Okay, so I'm just gonna have this to the side like that. Okay, that's visible. Okay, so if I look at this drawing and just take a look and analyze it. So we have a bunch of lines here, and then we have a few arcs, we have circles, we have a lot of dimensions, and notice we have constraints. So we have a tangent constraint right there, another tangent constraint, and just intuitively you'll know that this line is vertical, this line is horizontal, this line is vertical again, this line is horizontal, this line is horizontal. So just as you just look at the part, I would look at um, all the all the necessary all the necessary constraints or relations in the drawing. So yeah, so we have a bunch of measurements, we have all our relations, and like if you notice this point right here for the arc, the center of this arc is located on the line, and that's a coincident relation, and just stuff like that. So if there's anything else we see just looking through, that is the first step of the process. And notice how like this arc to the center is just random off to nowhere. So yeah, and our goal is to make this in SolidWorks and make it fully defined, because if it's not fully defined, it's probably wrong, and being fully defined is like the only way to make sure your model always stays like constant and true. Okay, so just looking at this, I personally feel like a reasonable place to start would be like this little bottom section. So that's where I'm going to put my origin. So remember how I said everything needs to start at the origin or like some dimension away from it. So let's just start at the origin. So what I'm going to do is I'm going to create sketch, and I'm going to just do it on the front plane for now. So I can zoom in just a little bit. And now let's get started. So first thing I'm going to do is this first line right here. So that little flat line. And then we have something that extends off to the at an angle. We don't know what angle that is, so I'm just going to leave it not defined. And then we have a line. So notice how this vertical line automatically has that little yellow relation pop up. So it's SolidWorks recognizes that this line is vertical and tells us that okay, so if you want, I can add this dimension in already. So let's add that vertical dimension while we're at it, and then we will do our this little angle, and again, they give us an angle for over here, but let's not specify that just yet. So we will first just draw out the general shape with the constraints and everything, or the relations and everything, and then we can start doing the dimensions. So now there's another horizontal line here, so let's add that in, and that goes approximately like right there. Okay, so just the horizontal, and now we need an arc. So I'm going to press escape on my keyboard, and let's take a look at what type of arc this would be. So we know three types of arcs. First of all, we have the tangent arc, and our starting point is going to be right there. So with the tangent arc, this is not tangent to the line at all. So a tangent arc is not really viable. Although this point on the other side is tangent, we can't really use a tangent arc because we're starting from this side. And next, let's look at the center point arc. So we also cannot use the center point arc because the center is not in a defined position and we don't really know where it is. So our best option is going to be a 3-point arc, and I'm going to select the 3-point arc, which is like a little semicircle with 3 dots. So I'm going to select the starting point and then do something that closely resembles but not exactly, something like that, and then I will just put down my center right there. So make sure I don't want any relations to go with this, so I'm just gonna make sure nothing snaps into place. So if I click here, you can see there's no existing relations, and that's good. So now we have the little arc, which is good, and now we need a line that goes from this arc to this another horizontal line. So let's do that. Something like that. Again, I know there's angles and everything involved, but let's not worry about that right now. And then we have our little horizontal line, and then we have one angle, vertical line, another angle, and a horizontal line. So that's going to be horizontal, right? Make sure no relations except horizontal, obviously. And now we have an interesting situation. So we have one arc and then a second arc right there. So I'm actually going to take a pause right here and work on this bigger arc because that is more important and it has more relations to it. So let me go into Solidworks. I'm going to press escape. Oh, here, let me delete this now. So I'm going to select my center point arc because we know that the center is on this line. And notice when I hover over the line, you can see the coincident relation. So I'm going to select that, and I'm going to select this point because this is where we want it to start. And just wrap around until we can get like an arc. So that looks pretty good. And again, so the center is probably not in the exact right place, and we'll worry about that later. But right now what we care about is that little relation. And then we have our tangent arc, and we can use a tangent arc here because the point we're starting at from right here is tangent. So we're using all three types of arcs in this example. So tangent arc, and again right now it's tangent to this line, but it's also supposed to be tangent here, and we'll worry about that. Okay, so right now it looks just very remotely similar, and that's because we haven't even finished all the relations yet, and once we do that and do the dimensions, we will be good. So first thing I'm going to do is I haven't done this tangent relation between this arc and this line, so I'm going to select those, hold shift and select those, and click tangent. So now we know that that relation exists. And then go back out. We know this right here is going to be tangent, but if I make this tangent, yeah, it's going to cause some issues. And when it does stuff like that, it's better to just like right for now ignore it and then worry about it later when we really need to. So other than that, all the relations are done. So we have this little circle inside, but we'll do that as the last step. So let's work on all the dimensions now. So I'm just going to start with this little 29, and we also have A and B dimension, which is going to be 81 and 57. And so let's start with the 29 first. So I'm going to do the 29 dimension, and I know that this is going to be 19. So 29 from this point to that line, let's first do that. This point to this line is going to be 29. And this line to this point, the center of the circle, or center of the arc, is going to be 19. Okay? And then we know that this is going to be 24, so from right there to right there, yep, that's going to be 24. And I know things are changing right now, that's perfectly fine. And I'm going to move this over a little bit so it resembles the shape still. Smart dimension, this distance is going to be 5. And then we know this angle is going to be 45. And then the radius of this arc is going to be 19. And then the tangent relations are done. That angle is going to be 10 degrees. So let's specify that angle. So notice if I select two lines, it'll give me the angle between that. So it's going to be 10 degrees. And then the distance from this line to right here is going to be 14. Another 45-degree angle right there. And notice, like, our sketch is still nowhere close to defined, but as we're adding the measurements, it will soon get there. So we know that distance is going to be 7 right there. And then we know the total distance from here to here is 32. And then again, so distance from here to here. Okay, so let's actually move this a little bit up so we can actually dimension this properly. So this distance is going to be 7. Yeah, 7, and then another 45-degree angle. And then the distance from this bottom to right here is going to be 19 as well. So okay, so let's do A right now. A is going to be 81. So go into Smart Dimension, select these two lines, and make this 81. And okay, so that causes some issues. So what I'm going to do is I'm just going to move things over until everything is fixed. So this can come down, this can be reduced. There we go. So slightly better, but still could be better. Okay, so we have the 81 relation, or the dimension, I mean, and then we have our 57, which is B. So I'm going to select, yeah, so select this line, yeah, that's way off, so make this 57. And okay, so we're starting to have slightly more defined measurements. So let's specify the radius of this arc. That's going to be 29. So the radius of this is going to be 29. And we know the radius of this is going to be 5. And notice it's still having some issues. And now we can actually start to make this tangent. So when I select this mix tangent, notice how that just aligns and define that whole thing. So we have that measurement. Now we know that just this thing is not fully defined yet. And we can define that by adding this 29 measurement. So from right there to right there is going to be 29. Okay, and now our sketch is fully defined. So after I added all the measurements that they gave us, my indicator, the definition indicator, turned from underdefined to fully defined, and none of my lines are blue, so that's a good sign. So the tricky part about the CSWA exam, they'll give you all the dimensions you need, sometimes a little bit more, but they'll never give you less. And another important thing to realize is you should never be doing like mathematical calculations like ever. So like for example, you're like, so this whole thing is A and this thing is 29. That means the distance from this line to this must be A minus 29. Like sure, that might be true, but sometimes it'll very easily throw you off, and um, it's best to just use the dimensions they give you. And then now we can do the circle. So circle, I'm just going to put down a circle somewhere. So the diameter of the circle is going to be 14. And we know it's the diameter because that symbol right there says that, means that it's the diameter. And then we know that it's 14 from each wall. So this distance is going to be 14, and then this distance is going to be 14. Okay, so now we have that fully defined too. And that's basically it. This is our sketch. So if I click exit sketch, and all this stuff we'll talk about in the next video. So this is the extrude function, meaning it'll just extrude the sketch, like push it out in one direction. So, and that's going to be C, which is what, 43. And so now I have a 3D part, and if I go into my isometric view, it looks pretty much exactly like this. So yeah, that is SolidWorks sketches and relations. If you have any questions, just put it down below and I will try my best to answer them. Thank you.